In Chapter 8 today, we're going to look at calculation of molecular formulas, and it's really simple once you know how to calculate the empirical formula. So by definition, a molecular formula is the exact formula of the molecules present in a substance. The molecular formula is always an integer multiple of the empirical, and this is the example mathematically where n is a whole number. So you're going to calculate your empirical formula. You have to do that in order to find molecular, and then you're going to multiply each atom within that molecule by a certain whole number to get the molecular formula. Okay, let's look at this example. A gaseous compound containing carbon and hydrogen was analyzed and found to consist of 83.65% carbon by mass. Here is a bit of information you've never been given before when doing an empirical formula. It tells you the molar mass. This piece of information is always given, always in the problem. You determine the empirical formula to be C3H7. What is the molecular formula of the compound? In order to calculate the molecular formula, all you're going to do is you're going to take the molecular mass. Wish I could write better. Divided by the empirical mass. And you're going to take that number and you're going to multiply it by the subscripts. So for example, it says that our molecular mass is 86.2. We now have to calculate the empirical mass. C3H7, just like we've done before, nothing new at all. So the empirical mass is 43.11. We take 43.11. We're going to take 86.2 divided by 43.11. And when you do this, you're always going to get a whole number. If you don't get a whole number, this is like 1.999, so that's 2. If you don't get a whole number, you've done something wrong. So you take that as a multiplier. So our empirical formula is C3H7. Back up and do that again. I'm going to take each subscript and multiply it by 2. So my molecular formula is going to be C6H14. So my empirical formula is C3H7. Molecular formula is C6H14, which is how this actually appears in nature when we go to find this particular compound, this hydrocarbon compound. This example has everything in it that we would expect to have in a problem that we normally do. So it tells us 49.3% carbon, 6.9% hydrogen, and 43.8% oxygen. If they didn't go ahead and tell you the empirical formula, you would be expected to do and calculate the empirical formula from the information that was given, where you would take the 49.3 grams of carbon and the 6.9 grams of hydrogen, the 43.8 grams of oxygen, and change those to moles and calculate your empirical formula, just like we did yesterday in class. When they've already done that for you and told you the empirical formula is C3H5O2. So in order to find the molecular formula, all we have to know is the mass of the empirical formula, and here's that piece of information that they gave us, the molar mass, or the molecular mass, is 146 grams per mole. So what we're going to do is calculate the empirical mass of C3H5, just like we've always done. And through the wonders of modern technology, we find out that quicker than if we had stopped and done it ourselves. We have 73.08 grams per mole. So now we're going to calculate the molecular formula. We have to take the molecular mass and divide it by the empirical mass. So we're going to take 146 from the problem, that's always given, and we're going to divide it by 73.08. And it's 1.997, so this is going to be 2, and that's our multiplier. So now I take My empirical formula is C3H5O2, and I multiply each subscript by that whole number. So my molecular formula is C6H10O4. So that's the answer to this problem. So one extra step is all it's adding in. So you actually will be going through this stage again and calculating the empirical formula like you did on yesterday's homework. Then your last step is taking this molecular mass, finding your empirical mass, and dividing it into the molecular mass, taking that whole number that you're going to get. And if it's not a whole number, you've done something wrong. This whole number, and multiply it by each subscript in the empirical formula to get the correct subscripts for your molecular formula.